In this video I am going to explain how can you calculate the equivalent resistance in a circuit when the resistors are connected in parallel. So why do you need to know about this? When we design electric circuits, we need to ensure that the right amount of current in that circuit as required by the appliance. So we can achieve that by adding the right resistor in the circuit. But the resistance of the desired value may not be available in the market. So it can be achieved by adding resistors in different combination. So resistors can be connected in parallel in the circuit, they can be connected in series in the circuit, they can also be connected both in parallel and in series. So I am going to talk more about the resistors in parallel. So as you could see in this circuit, the n resistors are connected parallel. You can also see that the one end of each resistor are connected together. Similarly, the other end of the resistors are also connected together. Now let's try to find out the equivalent resistance when three resistors are connected in parallel. So these are the three resistors in this circuit which are connected in parallel, and there is a power supply of V volt connected in the circuit, and the current is drawn by in the circuit is say I. Now as you can see that the potential difference across each resistor is same, and that is V. So let me note down this. So potential difference across each resistor is same, that is V. Now let's talk about the current. Now if you can see that current at this point is divided into three components. So it's basically current I is split into say current I1, I2 and I3. So that is I1 is flowing through R1, I2 is flowing through R2 and I3 is flowing through R3. So the current through each resistance is different. Okay. Now you can see that the current when it enters into each of the resistors, they split into three components, but when they exit from the branch, they again add up to the total current I. So I can write I equals to I1 plus I2 plus I3. Okay. So that the circuit below is basically the equivalent circuit of the above circuit. So here you are showing that there is one resistance which is the equivalent of all the three resistors R1, R2 and R3. Now as per Ohm's law, we know V equals to IR. If we apply Ohm's law in this equation, we get I equals to V by R equivalent, which equals to V by R1 plus V by R2 plus V by R3. Now if I can rewrite these equations in this way, taking V outside on both left hand side and the right hand side, I get the equation like this. Now I can eliminate V from both sides, and that gives me the equation to find out the equivalent resistance for the three resistors that are connected in parallel. Now if you have more than three resistors are connected in parallel, say n resistors are connected in parallel, in that case your equivalent resistance would be 1 by R1 plus 1 by R2, continue like that, and plus 1 by Rn, and that gives you the equivalent resistance for n resistors when they connected in parallel. So as you can see that when the resistors are connected in parallel, the equivalent resistance basically is getting reduced. So now I will show you few circuits where resistors are connected in different combinations. You may find this interesting, and you can try to find out the equivalent resistance for each of these circuits. Thank you for watching this video. Hope you enjoyed this. You can learn more at Vedantu